Hey guys, Winston at Carbide 3D here. You can't machine what you can't hold in place, and though there are plenty of options for work holding, few methods are as quick and reliable as bolting your part or clamps down to a pattern of threaded inserts. It's arguably the most cost-effective way to attach things to your machine, either temporarily or permanently. Additionally, by adding a piece of MDF on top of your wasteboard and installing inserts in that instead of the original wasteboard, you can machine level your cutting surface to ensure your part sits flat relative to your gantry. So today, I'll walk you through how I made an MDF table with threaded inserts to attach to my Shapeoko, and also how you can design your own. The threaded inserts I'll be using are the ones we carry in our store. We offer both M6 and *20 inserts, so regardless of your unit loyalties, we've got you covered. These inserts, regardless of type, will fit snugly in 9mm holes plus or minus a few tenths of a millimeter. The nearest fractional drill size you could use would be 11/32 if you want to try to drill these out by hand, or if you don't have metric drill bits, but being that you probably have a CNC at your disposal, it's pretty obvious how we should proceed. You all know Fusion 360 is where my personal CAD/CAM loyalties lie, so I'll show you how I designed my threaded table there first. I planned for my design to be 350mm deep by 390mm wide, machined from 3/4 inch MDF. You could make yours a little bigger, but I wanted to keep a comfortable margin all around to guarantee its machinability and ensure that the entire surface could be faced even on machines like HTZ equipped Shapeokos, which stick out a few millimeters further from the gantry. I'll also set up an array of 6.8mm holes that are a multiple of 50mm away from each other. The aluminum bed option on the stock Shapeoko 3 has holes that are in a 50mm grid. Even though that aluminum bed is a ton more rigid, there is still some benefit in having a surface on it that can be machined absolutely flat. Now, just because I used millimeters previously doesn't mean that I'm a metric sympathizer. My own hole pattern for threaded inserts will be in inches. If you're making your own threaded wasteboard, feel free to pick whatever increment you want. I personally like 1.5 inches because the hole spacing to install a Carbide 3D low-profile vise is nominally 3 inches. Each of these holes will be 9mm in diameter. With these holes patterned out in the mounting holes for the threaded wasteboard counterboard, I can move on to create some toolpaths. To start, I'm going to use a boring operation on one hole. Boring operations in Fusion will spiral down to whatever depth you specify, eliminating the shock and vibration and even burning you might get from plunging an end mill straight down into wood. Not only that, but a boring operation gives you flexibility in what size hole you create instead of limiting you to the diameter of your end mill or drill. All you need is an end mill that's smaller than the hole you want to make. 9 times out of 10, boring is the easier choice for making small holes rather than drilling. For maximum precision, I'm going to run my boring operation a second time just to trim off any material that was missed the first time. But since it's going to be a very light cut, I can afford to increase my pitch, making that spiral path of the end mill a lot steeper and faster. I'll create a pattern in order to apply these two toolpaths to the rest of the threaded insert holes. For my mounting holes, I'm using a pocketing operation inside my counterbore, followed by a boring operation to punch through to the bottom of the MDF. I'm not running it a second time because this hole is comfortably oversized and its dimension really doesn't matter. There's no threaded insert going into this hole. However, because the diameter of the hole for the mounting hardware is so close to that of the end mill, I'll reduce my pitch so that the angle of the spiral is less steep. And then, finally, I'm going to use a contour toolpath to go around the MDF and cut the whole thing out. All of our toolpaths will use a 1/4 inch end mill like our 251. I'll export these operations all as one G-code program. Now, what if you're not ready or don't want to use Fusion 360 to design your own wasteboard? Well, you can very easily make a pattern of holes using just about any vector graphics editor, including Inkscape. Just draw a 9mm circle and then pattern it out with your desired spacing. Then just export it as an SVG and import that SVG into Carbide Create. The toolpathing for these holes is pretty simple. Just select all of your circles and apply a pocketing toolpath to them. The default speeds and feeds for MDF and a 1/4 inch end mill are fine to start with, but of course feel free to use your own recipe. If you want that extra guarantee of accuracy in the dimension of your holes, you should run a spring pass. Create either another pocket toolpath or a contour toolpath inside the circles. Here you can use a much more aggressive step down and plunge rates. If you want to cut a small counterbore so that the flange of the threaded insert will sit below the surface of the MDF, you don't need to draw any additional features in your design. Just create a contour toolpath with no offset right on the circle for the hole and cut that to a depth of about 1.5 to 2 millimeters. That will give you a hole that looks like this. Just remember that the flange side of the threaded insert should ideally be on the bottom of the wasteboard to help prevent it from being pulled through the hole. That means any counterboard features for recessing mounting hardware, like the ones you saw in the Fusion 360 version of my supplementary wasteboard, would have to either be machined in a separate operation after flipping the MDF over, or put in manually with a Forstner bit. So now that we have two ways to design a threaded MDF table under our belts, let's cut one out. I've taken the liberty of manually cutting a sheet of MDF down to near final dimensions, plus about 3/4 of an inch of margin to account for inaccuracies when I set my zero location. Now, while this table would technically be entirely machinable upon the original wasteboard of the Shapeoko, the jutting front lip of the machine makes doing this extremely risky. As insurance against unexpected steel machining, I would recommend elevating your stock. Some double-sided tape on both sides will be good enough to hold everything in place since I'm planning on using a down-cutting end mill. This will also let you overhang stock in front of the machine slightly to ward against hitting the positive y-axis limits. If you have a bit setter that's in the way, you can remove it from your machine and deselect bit setter in the Carbide motion settings. Just remember to rehome and re-zero your Z height after doing this, since the work position of the machine is now missing a tool length offset value and may now be invalid. Pro tip, it helps to mark where your bit setter should be installed with some tape, and to also write down the bit setter's offset value for that position. Once you're set, you can run the programs and come out with something like this. If you mark the position of your cutout piece with tape or 1, 2, 3 blocks or something, you can flip it over and machine some countersinks or counterbores while keeping your piece centered in exactly the same location. But I was impatient when I made this and used a countersink bit in a drill to allow my threaded inserts to sit below the surface of the MDF. I find it easiest to drive in threaded inserts using a drill with an adjustable slip clutch and a 6mm hex bit. Once you get that clutch setting just right, you can fly through a whole wasteboard's worth of inserts in no time. This supplementary threaded MDF wasteboard now fits perfectly on a Shapeoko 3 with an aluminum bed. If you need this installed on a naked MDF wasteboard, just use your threaded insert wasteboard as a template and use a punch or marker to transfer the mounting hole locations to the original wasteboard. Using a drill and the appropriate sized bit, you can install 4 or 6 threaded inserts into the MDF and bolt down your supplementary wasteboard. Overall, this should be a really straightforward project that will make your life a lot easier in the shop. You can also make your own threaded wasteboard designs or customize the MDF panels that we ship with T-Track kits. But if you're not up for making your own design for whatever reason, I will be providing links to 2 options on CutRocket, one designed by me and one designed by Ed Ford. My feelings won't be hurt if you like his better. If you have an XL or XXL, you can also machine multiples of these wasteboards and tile them to cover your reachable work area. That way you can replace individual sections in the event of a CNC-related mishap. I hope this video gives you some insight into a really simple but worthwhile DIY upgrade to your CNC experience. Until next time, good luck and have fun machining, folks.